You ever look at a massive skyscraper or a really complex bridge and just think, wow, that is precise. It looks like every single piece fits together perfectly, right down to the millimeter. But what if I told you the real secret to their strength isn't perfection at all? It's actually a brilliantly managed system of, well, imperfection. Okay, let's get into it. So, the big question right off the bat is with all our modern tech, laser measurements, computer aided design, all that stuff, is perfect construction even possible? Can we actually build a truly flawless building? And the simple answer is nope, not even close. And what's wild is trying to achieve it would be a terrible, terrible idea. The fact that perfect construction is impossible is actually what keeps our buildings standing strong. Sounds totally backwards, right? Well, let's unpack why. So, first, we got to tackle this big idea, the myth of perfection. We really need to understand why the messy reality of a construction site can never, ever match those clean, perfect lines you see on a blueprint. This slide really lays it all out. On the left, you've got the blueprint. It's this perfect digital world where every line is straight, every angle is exact. It's pristine. But then, you get to the real world on the right. This is a place where steel actually expands and contracts with the heat. Concrete has tiny little variations from batch to batch, and even the most skilled worker isn't a robot. Reality is, well, it's messy. So, what happens if we just ignore that messy reality? What if we pretend everything is going to fit together perfectly? Well, that's when you run into a really dangerous problem that engineers call misfit. And misfit isn't just one little problem. It's a whole cascade of failures waiting to happen. See, if one steel beam is just slightly out of place, you might have to force it to connect. That force, that creates hidden stress. That stress makes it harder to attach the next piece, which can lead to gaps. Those gaps can lead to leaks. And all of these tiny compounding problems can seriously compromise the integrity of the whole structure, maybe even causing a failure years down the line. And look, this isn't just some casual observation. This is a fundamental law of engineering. A structure's ability to handle weight, wind, everything, its very behavior, it all comes down to proper alignment. So when you ignore the natural expected variations in materials and assembly, misfit isn't just a risk, it's a certainty. So, if perfection is impossible and misfit is inevitable, how do we build anything safely? This is where engineers introduce the real hero of our story, a little concept called tolerance. So what exactly is tolerance? It's really just a pre-planned, totally acceptable range of imperfection. It's an engineer saying, listen, I know this concrete column won't be exactly 500 millimeters wide, but it absolutely must be between 495 and 505 millimeters. It's a defined zone of good enough. Now, to be super clear, tolerance is the absolute opposite of being sloppy. It is not an excuse for bad work. It's a highly precise, very calculated system for controlling the chaos of the real world. It's all about intelligent management. Okay, so that's the theory. But how does this actually work in practice? How do crews on a loud, busy, chaotic construction site actually put tolerance into action? Well, it's a super disciplined four-step process. First, long before anyone even breaks ground, engineers define the acceptable tolerance for every single part. Then, out on the site, crews measure absolutely everything. Next, a quality control team comes in to verify that those measurements are within that allowed zone. And finally, if a piece is outside that limit, it's not jammed into place, it's adjusted or, if need be, completely replaced. Define, measure, verify, adjust. That's the rhythm. And as you can see here, tolerance isn't some one-size-fits-all number. A massive concrete foundation, it might have a little wiggle room, maybe 15 millimeters. But a delicate glass facade panel that has to be perfectly weatherproofed, oh no, that might have a teeny tiny tolerance of only 3 millimeters. Every single value is custom tailored to the specific material and what it needs to do. So let's bring this all home. What does this whole system of controlled imperfection really mean for the buildings we walk in and out of every single day? Well, it's pretty simple. It's the invisible foundation of their safety. Think about it like this. You can have the strongest steel beam in the world, but if it doesn't fit correctly with the other pieces, its strength is basically useless. You could argue that 99.9% of a structure's safety relies not just on strong materials, but on the simple fact that all its parts connect exactly the way the designer intended. And that's exactly what tolerance makes sure happens. At the end of the day, that's what tolerances are. They're the invisible language of construction. They take all the chaotic, messy variations of the real world and turn them into a system that is controlled, that is predictable. And in engineering, predictable performance is safety. So, the next time you look up at a skyscraper, what are you going to see? Are you going to see perfect, flawless lines? Or will you see something that's honestly way more impressive? The beautiful result of a brilliant system of perfectly managed imperfection holding it all together.